Okay then. Welcome to this course on numerical methods. Then first of all, let me give you a brief review of the materials we are going to cover. Is my screen visible now? Okay then. So obviously today is the first class, and today we are going to discuss the uh, introduction to Python, and tomorrow also we will discuss about Python. But from the third class, we will discuss the numerical methods. The first thing in the numerical method we are going to discuss is the interpolation. Right. So what is interpolation? Do you know about interpolation? Okay, if you don't know, so I am giving you a brief idea about it. Suppose you are doing an experiment. This is a setup for finding the Hall effect, and during such an experiment, you usually measure some data, right? And in this experiment, we measure the current and magnetic field. We pass some current in these coils, and then we measure the magnetic field produced by these coils. So corresponding to this current 0 ampere, here we have the magnetic field as 105 Gauss. Similarly, for the current 0.04, we have the magnetic field as 174 Gauss. But suppose you need the current at 0.003 ampere. How to find it? So to find it, we need a method called as the interpolation. So how to find this in between data values? That is you can find using the interpolation methods, right? So there are different methods to do interpolation. The first one is Newton's interpolation. Then we will study about the Lagrange interpolation. Then we will discuss about system of linear equations. In lecture 5 and 6, we will discuss about linear equations. What are linear equations? You may know from you may know them from the Kirchhoff's law. When you solve a circuit using applying the Kirchhoff's law, you may encounter equations like this. Something like this: 5i1 minus 6i2 equals to 0, or 10i1 minus 7i2 equals to 0. So when you solve a circuit using Kirchhoff's law, you find what is the I1 and I2 values, right? What are I1 and I2? These are the current values, the current in the circuit, right? So these are a system of linear equations, or you may write in this form. This is in the physics. In mathematics, you may learn about them. That is, suppose like 5x plus 3y plus 5z equals to 0, x plus 2y minus z equals to 0, 3x plus y minus 7z equals to 0. These are a system of or this is a system of linear equations. Here you need to find what are the values of x, y and z. So these are very useful, and in physics and mathematics you often encounter them. So that is why we are going to learn about them, how to solve them in computer using these numerical methods. Then in lecture 7 we are going to discuss about curve fitting. What is core fitting? Yes, here. Suppose you have some data and you want to find what function matches this data, or when you do experiments like finding the or verifying the Ohm's law, right? Ohm's law. In 11th or 12th class, you may have done an experiment to verify the Ohm's law. So how to verify? So how you proceed? Ohm's law is what? V is R into I, or voltage equal to resistance into current, or voltage is proportional to current, or you can also write that I is proportional to V. So you plot a graph for corresponding I values, you plot the voltage values and you get some data points, and then you try to find the straight line which matches these data points using hand you used to do in the 11th or 12th class. That is known as the core fitting. What is the most accurate line that represents these data, right? This is known as core fitting. So that can be done in computer also. What is the most accurate function or line that matches these data points? That is called as the core fitting. And we are going to learn about them, how to do them, do them using computers or using the numerical methods. Is it okay, or is there any doubt so far? Ayush? Okay. Yeah. So then, uh, yes. Oh, so I was just asking, is there any doubt so far? Okay then. So in lecture 8, we are going to discuss about the roots of algebraic and transcendental equations. I will tell what is a transcendental equation in that class, but you know what are the algebraic equations? The algebraic equations like the linear equations, the quadratic equations. You know this, to solve a quadratic equation, you know this famous formula. And then there are cubic equations also, and there are many other types of algebraic equations. You used to solve them by hand, and I will teach you how to solve them using a computer, using some numerical methods. And there are other equations known as the transcendental equations. The example is like this. When you study diffraction, if you ever study diffraction in optics, so you encounter to solve such a equation. These type of equations are known as the transcendental equations, and there are many methods to solve them: the bisection, secant, Newton-Raphson, regular-Fulci, and these are the 4 methods to solve them, and we will discuss about them in the lecture number 8. Then lecture number 9, numerical differentiation and integration. This is obvious. You used to do differentiation and integration in 11th and 12th class by hand, but you can also solve them or also differentiate or integrate functions using computers. There are different methods to differentiate and integrate. For differentiate, we are only going to learn about the finite difference method. This is the easiest one. And for the integration, for the numerical integration, how to integrate functions using computers. We are going to learn about several methods: the rectangle rule, trapezoidal rule, Simpson's rule, and others. These are we are going to discuss in the lecture number 9. Then lecture number 10. In the lecture number 10, we are going to solve the ordinary differential equations. And we are going to learn about only two methods. The first one is known as the Euler's method, and the second one is known as the Runge-Kutta methods. So these are the lectures we are going to follow, and today especially we are going to learn all about Python. I am not going to teach everything about Python, just the things you require to do all these things. Now you may be familiar with other programming languages, but I am going to follow Python. And here I am going to give you all the algorithms, and if you are interested in doing using another programming language, you can do it. That is no problem, but I am using Python. Okay, so let's discuss about Python now. Let's start our first class, and let me stop sharing here, and I am going to sharing now using my laptop. Okay. So is my screen visible now? Is it visible to everyone? Okay then. So this is the first lecture on Python. So can you read these lines? Yes. Okay then. Okay, let's start. So introduction to Python. Why I am going to use Python? Why not any other language? Because the Python is one of the most used languages, and it is very easy to write. But it is very easy to write and read. The syntax of the Python is very straightforward and similar to English. So it is a very beginner friendly language. And the second point I have written is that it is an interpreted language. What is the meaning of an interpreted language? Python is interpreted line by line, making it easier to debug and ideal for interactive development. So you may know that there are two types of languages. One is known as the interpreted language, like the Python, and there is another type of language known as the compiled language, or like C and C++. So those require compilation. So what is the meaning of compilation? So when you write a program in C or C++, what they do, they compile the whole code first. Means what they do, they convert your writing to machine language. What is a machine language? Machine language is those binary codes 0 1 1 0 0 1. This is known as the machine language. So they convert your whole code to machine language, and then they interpret it or they find the result. But in Python it is not like this. They don't compile the code first. The Python is interpreted line by line. So it goes from one line to another line. It does not compile the whole code. It interprets line by line. This is the feature of Python. This is a good thing about Python. It makes things to debug or find the errors easily. But it is also a disadvantage of Python. As Python goes line by line, it takes more time to run. So that is why languages like C and C++ are very fast than Python. So most of the in this numerical astrophysics, where they run very large codes to solve problems like the black hole collisions and or neutron star collisions, they most of the times they use C++ or C. Most of the times they use C++. They very few people use Python, because Python requires a very large time to run those codes. So Python has a efficiency problem, but it is very beginner friendly. So that is why you should start with Python. Then the third point is dynamic typing. What is dynamic typing? In Python you don't need to declare variable types explicitly int for integers, and Python figures out these types automatically. So in C or C++, when you declare a variable, suppose x equal to 1.5, there you need to declare what kind of variable you are using. But in Python you don't need to declare the variables. So that is why it is known as the dynamic typing. And Python has vast libraries and ecosystems like NumPy, Pandas and SciPy. For our purposes, for the physics people or the people in science, we usually use the NumPy, Pandas and the SciPy. So these are important for us. So that is why we use Python, because Python has a huge ecosystem of libraries and frameworks. Okay, let's start the Python basics. Okay, is there any doubt so far? Okay then. Is someone trying to join? Yes. Okay, let's start our class now. Let's start our first Python tutorial. The first program we are going to learn is obviously how to print something. And before that, how to comment something. And to comment something on your code, use this hash or pound sign. Hash something you want to write. This code is written by Sagar, or something you want to write, and that is not going to be compiled. This is just a comment. And how to give a multi-line comment? This is a one-line comment. Now how to write a multi-line comment? So this is how you write a multi-line comment. So using 3 double quotes, right? These are the 3 double quotes. Like this. And between these 3 double quotes, you may write anything. Like this. This is a multi-line comment. then our first program, the first program is to print anything. To print anything, just write it between these double quotes, right? So here are these double quotes. Between these double quotes you can write anything. Hello multiverse, hello world, anything you can write. And compile it, it will give you the result. Hello multiverse. Then the next thing, or the first thing we are going to discuss about Python are the data types. So what are the different data types available in Python? In Python, a data type is a classification that specifies the kind of value a variable can hold. When you are defining a variable in Python, that variable can hold different data types. That can be an integer, that can be a decimal number, having a decimal point, and that can be a complex number or fraction or anything. So there are different types of data types. The first type we are going to discuss are the numeric types. These are the numbers, right? So in the numeric type, the first type of data type is integer. So what is an integer? Integer, it represents a whole number or a positive or negative number with no decimal points. There is no decimal points like this 90.76. There is a decimal point, but these integers are numbers having no decimal points. So these are the integers, or the class is, their class is int, int. These are a class of data and their class is represented by int. Then floating point numbers. These numbers having a decimal point are called as floating point numbers and their class is known as float. This float, float. These are this 3.14 minus 0.001, 2.0. These are known as float. Then complex numbers. Complex numbers in Python, they are defined like this: 3 plus 5j, where this 3 is the real part of the complex number and this 5 is the imaginary part of the complex number, right? So that is how you define integers, floating point numbers and complex numbers. So here are some examples. This b is minus 8787 and c is 90.76. Now if you print, what is the type of b? There are two variables b and c. Now if you type what are the, or if you write here print type of b and print type of c, it will give you class int and class float. That means this b variable holds a data of integer type and this c variable holds a data of float type, right? And here this d is 3 plus 6j. That means this d is obviously a complex number. Now if you print d and its type, it will print this d, the value of d, and its class is what? Complex, right? These are the numbers: integer type, floating type and the complex type. Then there are other numbers also: binary, hexadecimal, octal number. A binary number starts with the code 0b. After 0b, if you write the binary number 1010, right? 0b, 0 capital B, 1010. So this 1010 actually represents 10 in the decimal number system, right? And if you type what is the type of e, it will be integer type, not binary type. So if you store a data like this binary type of data, this will be stored as an integer type. And similarly, the hexadecimal type numbers start with 0 and x, and the octal type of numbers start with 0 and o. If you know about these numbers, then it is fine, and if you don't know about them, it is okay. You can learn about them later. These are not very important for our course, but these are the types that is also available. You just know. Then the second type is text type. The first type was numeric type, right? These are the numbers. These are the numbers you can store in a variable. Then the text type. What is the text type? Here you may store some text in a variable. Suppose this is a variable string. The name of the variable can be anything, string, and here you are storing a text or a line. This is not a number, right? So this is a line you may store in a variable, and if you now print this string, this will show you the line you have given as input. Then if this is the string 1 and this is the string 2, there are two strings now, and if you want to add them, you can also add them like this, that string 3 is string 1 plus string 2. That is how you add the strings. Add the strings, right? So the string 3 is the addition of two strings, string 1 and string 2, and this will give you the string, the resultant string. You can add them together. Now if there is a string like this is known as this is a string, and now if you just print it, you can print a string like this, and this is something known as the indexing. In a string there are indexing, so this is going to be a bit boring, so just hold into it, that in a string these letters have index. So this S has the index of 0, this U has the index of 1, and this R has the index of 2. So that is how indexing appears, right? So the indexing is like this. This S is 0, then 1, then 2, then 3, then 4, then 5. Then this space is also this space also has a index, and it is 6, like this. And then obviously you have opposite indexing. So this N has the indexing of -1, this A has the indexing of -2, and this M has the indexing of -3. So why this indexing is there? This indexing is there to retrieve a part of your string, or to access a part of your string. Suppose you want to find what is the first element in this string, then you can access it by writing k of 0 like this. Or then suppose you want to access the second element of the string, then you can access it by writing k of 1, right? And this length of k, or len of k, this gives you the whole length of the string. What are the how many letters are there, right? So if you count them, this will be 33. There are 33 variable, there are 33 elements present in this string, right? And here the length of the k will be 33, and here you see that k of 0 is S and k of 1 is U, right? Is it okay, or is there any doubt? Right? Okay then. So you are getting this indexing, right? This k0, k1. So this k0 is s and k of 1 is u, right? So that is how you do the indexing. Now the string type is immutable. Immutable means you cannot change this s. You cannot write k of 0 equals to m. You cannot change this now. If you are defining it, you cannot change it now. Like this, you cannot change. You cannot change this first letter as m. So here it will give you an error. The string object does not support item assignment. Right? That is why the strings are known as immutable. The strings are immutable. They cannot be changed after creation. You can access the characters by index, slice them, and use other methods, but you cannot change them. So these are the data type known as strings. Then string slicing. So here, what do you mean by slicing? You can cut them. You can just find the things you necessary. You can just write or print the things you have necessary. You need to find. Suppose you need to find the characters from 0 to 6. So what are the characters from 0 to 6? It is 0, S is 0, U is 1, R is 2, then 3, 4, 5 and 6. So if you print the value of k from 0 to 6, this is 0 is start and 6 is the end. You can print the characters from 0 to 6 or print the elements from 0 to 6, and 0 to 6 elements are surely only. It is surely, not anything else. Then you can also print the string from 0 to 9, from 0 character to 9th character in the steps of 2. This 2 is the step value. Let me write. 2 is step value, right? So here, what do you mean by the step value? If you write this 2 now, it will, when it is printing, it will skip an element. You see here, when it is printing this surely, it is skipping this u, then it is skipping this e, then it is skipping this y, and then it is printing again. So it is skipping one element after one element, right? So this 2 is the step value. And similarly, there are other methods, like here, if you want to print the element or the strings in the reverse order, you may use this -1 reverses the string. This -1, this step value as -1, that means it is telling you to print the string in the reverse order. The step value is -1. And what is k of -1? K of -1 is this element n, this character n. So that is how you do the indexing. It is the indexing from the start, from the left, it is like 0, 1, 2, 3, 4, 5, 6, and the indexing from the right, it is like -1, -2, -3, -4, like this. So here the thing to notice that, or very important to remember, that the indexing starts from 0, not 1, right? The indexing, it starts from 0, not 1. And when you do the indexing or slicing, so here if you write 0 to 6, it will go from 0 to 5th element, not 0 to 6th element. It will go to 0 to 5th element, not 6th. Now these are some other methods. If you want to find where is A in this string, where is A? The first A is here, and it will give you the index of the first A that appears in the string. The index of first A is 11 here. right? So find A means that will give you the index of the first A that appears in the string. Then K dot count A. So it will give you how many A's are present in the string, right? So if this is the string, then you see that there are one A here and another A here, right? So there are two A's in this string. So you see that K dot count is A. So you have two A's now. Is it okay? Is it okay, or is there any doubt from this section? Okay, then formatting. So these are a bit boring, right? But you need to learn this to do this numerical methods. Then formatting. So if you have if you want to input some variables inside the string while printing, you may write them in this way. So here suppose the one variable is x and another variable is 52 and another variable is this is a string type name, having a name, and if you want to print the string like this, you may input the variables inside the string like this, inside the curly brackets or the braces. Inside the braces you need to input these variable names, and when you print them, that will automatically generate the name and the numbers inside the string. You may do like this or do like this. So there is this F here, this format, and you need to write the F and then put the string inside the double quotes, right? So here you may have noticed that all the strings are inside the double quotes. So the strings represents a sequence of characters, and strings are used for textual data and are enclosed in single quotes or double quotes or triple quotes for multi-line strings. The strings are always between a single quote or double quote or triple quotes for multi-line strings. So this is the formatting, and there is something known as placeholders. This %s is called a placeholder for string types. So this a colon %s means this %s, that means this thing here holds a string type of data. And now if you write here in this format %s, then the name, and if you print this string, it will give you the a colon the name, right? And here also these are something not very important from our purposes, but here you just know that this is how you can do the formatting. This %f holds a float point data, and this %s obviously holds a string type data, and this %d holds a integer type of data. These are known as placeholders, and there are some other methods to do formatting also. Then some more methods. The more methods are like this string one. If there is a string and you want to write all these letters in capital, then you can write string dot one upper, right? And if you print this will give you all the letters in capital. And then print string dot one lower, so that will give you all the letters in the lower capitals, all the smaller capitals. The one piece is real, and this is in smaller letters or the lower one, and this is in capital. Okay, let me take a break and find my water bottle, and in the meantime you can also drink some water, and I am coming in just 1 second. Okay, let's continue. So these are everything about strings. You may then also these are the upper and lower types, right? And then if you want to replace something, suppose you want to replace this one with another word, then you can use this replace function in the string. So string one replace one with pick, and then that will replace you, and this is the result, right? In the place of one, it will replace another word, and that is how you can change a string using this replace method. Then so is there any doubt from this string type, or is it okay? Okay, then there are sequence types. So what are the sequence types? Different sequence types present, and these are list, tuple, and range. What is a list? A list is an ordered, mutable sequence that can hold a collection of items, which can be any data type. Lists are defined using square brackets, for example, like this. So what is a list? A list can hold different data types inside it, right? So here this X is a string type, and this 1 is an integer, and this 3.5 is a float. So this list can hold different data types inside it, as many as you want. This is the list, and if you want to print A, it will print like this. This will print the whole list. And there are we are going to discuss some methods in the list. So now if you want to remove something, suppose you want to remove this one, how to remove it? So just write a dot remove 1, this element 1. Now if you print A, it will give you just X and 3.5. This A is removed. Now if you want to change this 3.5 to only 5, so you can write A of 1 is equal to 5. And similar to the strings, there is indexing also. So what is this index of X? It is 0. What is the index of 1? It is 1. And what is the index of 3.5? It is 2. So 0, 1, 2. In the list, there is also indexing. So if you want to change this 5, then A of 1 can be equal to 5. So now this 3.5 will become 5, right? Now you can also add an element to a list. Suppose you want to add 2 to this list, and then you need to write a dot append equals to, and then print a. It will give you x, 5 and 2. So that is how you remove an element from a list. Then you can mutate an element in the list, and you can add an element to the list. These are the three operations. These are the three main operations you can perform inside a list. The lists are very important for our purposes. In these numerical methods, we are going to use this lists very often. Then you in the same way you used the slicing in the strings, you can also do the slicing for the lists, right? But for a list also you can do the slicing, that is from 0 to 7. It will print the elements from 0 to 6th element. So this 21 is 0, then 1, 2, 3, 4, 5 and 6. The 23 number is the 6th element. So if you print the elements from 0 to 7, then it will go from 0 to the 6th element in the list. It will not go from 0 to 7, it will go from 0 to 6. So that is important to remember, that when you do slicing in a string or in a list, the indexing goes from 0 to 6, one number less. It will go from 0 to 6, not 0 to 7. And similarly, you can do all these things here. This 2 is the step value, similar to the string type. All these things you can do, go through them and have fun with it. How to do different type of slicings. Then few applications. Now if you want to know how many elements are present in the list, you can do this way: length of A or len of A. This gives you the length of the list. So here you see the 11. There are 11 number of elements present in the list. You can also write sum of A. Sum of A means what are the sum of all the elements in the list, right? So it will add all the elements in this list, and it will give you the sum of them. This is the sum of A. And then you can also write mean. The mean will be sum of the A and length of the A. That is how you find the mean, right? The sum of the elements and the length of the elements. That is 35. And what is the maximum value on the list? Maximum value of the list you can also find maximum of A and index of maximum A, at what position the maximum value is present. The minimum A we can also find. Then sorted A, you can sort the values in the ascending order. So here you see that 5, 6, 7, 9.5, right? So these are going in the ascending order. You can sort them. Then if you want to sort them in the descending order, means first 100, then 90, then 67. So this is the descending order. To sort them in the reverse order, so you need to write sorted A reverse equal to true. So when you perform these functions, sorted and this sorted A reverse true, it does not change the original list. The original list is like A only. It does not change the original list. It doesn't change this. It will give you the sort. It will give you the sorted list only. Now if you perform the sorting like this, A dot sort, it will change the original list. Now A is completely like this. The A has lost its form, The A is a new list now in this way, in this form. The original list is going to change, and you can also sort them in the reverse order also. Now if there are a number of strings or text type data inside the list and you use sorted B, it will give you sorting by sorting alphabetically, right? First A, then E, then F, and then M, right? So that is how the sorting works for strings. And then if there are number of data and you want to count what are the occurrences of a single element, how many elements present of single type. Suppose you want to count how many 6 are present in this list. So you can just write c dot count. If c is the list, then you can write c dot count 6. How many 6 are present in the list? This will give you 3. There are 3 6s present in this list, right? And then you can also add the lists. Print A plus B. It is not going to add the element wise. It is just give you the total list. So it will add all the elements. This is one set of element. Then there is another set of elements. It will just add the two lists together, join them, and you can also join them using this also. Or just if you want to write all the strings or the elements twice, then you need to write 2 multiplied by A. Then it will give you the same list again, right? Then there are tuples. So these are lists, everything about list. So we discussed all about this list because the list is the sequence type, that is we are going to use the most. That is why we discussed everything about list. Then there are tuples. We are not going to use the tuples much. So this is a tuple type. Here the elements are just like this. There is no bracket. For the list, there you need a square bracket. The list is defined inside a square bracket, but tuples you don't need any brackets, or you may write them inside the circular brackets, right? Or inside the parenthesis. Inside the parenthesis, if you define the numbers, this will become a tuple type. And tuples are immutable. You cannot change the tuple elements, but you can change the list elements. This is a tuple type. And there are other types also. A dictionary type, mapping types are known as dictionary. These are much used in Python, but we are not going to use them in our numerical methods course. So that is why I am skipping them. So these are the mapping type. Mapping type has dictionaries, and set types. Set are defined inside the curly brackets or braces. Then there are Boolean types and non-types. So a Boolean type represents true or false. So the Boolean type stores a true or false data. Suppose this G is equal to true. And if you type the print of type of G, then it will give you class bool. It is a Boolean type data. The Boolean type has only 2 forms, true and false. So if you now print what is 9 greater than 7, it will give you the value as true, because 9 is greater than 7. So this Boolean type data are used for these purposes, to check if 9 is greater than 7, to check it, this Boolean type of data is used. And there is non-type. Non-type has no value, just a dummy value, that if you write n equals to none, it doesn't have any data, it is just empty. This n has empty value, and if you write the type of n, it will give you class is non-type. Okay, so these are the different types of data, and you can also convert if there is a float type data, you can convert this float type to integer type by writing h equal to int x. If you write int x, it will convert this float type to a integer type. So this 33.5 will become 33 only. So you can convert float to integer, and you can also convert the these decimal numbers to binary, octal and hexadecimal number also using this. Okay, these are all the data types. Everything about data type you need to know. Now, is there any doubt? So far, is there any doubt? Okay. Okay, then so let's move ahead. Now let's discuss about the operators. So there are different type of operators. The first one is arithmetic operator. Then the second one is comparison operators. The third one is logical operators. And the fourth one is assignment operators. Right? So first one is arithmetic operators. These are the basic operators, you know, the addition, subtraction, multiplication, division, float division, and modulus and exponentiation. These are, you know, addition, subtraction, multiplication and division. These three are new. This double slash is known as the floor division. This floor division divides and returns the integer part. It ignores the remainder. That means this floor division gives you the quotient only. It ignores the remainder. It gives you the quotient of division only. And what is this percentage? Modulus. Modulus, it returns the remainder of the division. If you divide a number, then it will give you the division. And exponentiation, it is obviously 2 stars. It raises the first number to the power of the second. Suppose square or cube. If you want to take the square or cube of a number, you use these operators, star, double star. It is for exponentiation. Then there are comparison operators. Okay, let me show you. Here you are dividing 88 by 7, right? 88 is divided by 7, and the answer is this. So this gives you the answer, the result. Now if you do the floor division, means two slashes, 2 backslashes, it gives you the quotient of division only. It will give you the 12 only. It will ignore the remainders and it will give you only the quotient of division. Then 88 divided by 7, it gives you the remainder only. The remainder is 4, right? And now if you write 5, this 2 stars 2, then it is 5 square and it is 25. Or if you want to find what is the cube of 5, then 5 double star 3 is 125. And then these are so these were these first 4 were the arithmetic operators. Then there are comparison operators. Comparison operator means they compare things. So if this 5 is equal to 5, that is true. If this 5 equal to 6, no, it is not true. So it will give you false, right? So these are to compare numbers. Is this 5? This exclamation mark and this equal to, it is that is not equal to 5, not equal to 4, it is true. 5 not equal to 5, it is false, right? Though this is not equal to symbol. And there are some other assignment operators also, other operators known as the assignment operators. So here this equal to is a simple assignment when you have a variable and you want to assign a data to it, you use the only this equal to sign. And there are add and assign, subtract and assign, other assignment operators. So if there is a variable c and a variable d, both have 10 value, then c plus equal to 10, that means c equal to c plus 10. This is very often used in programming. Instead of writing c equals to c plus 10, we write like this, c plus equal to 10. Or if you want to write d equals to d into 10, then you write like this, d into the star symbol equal to 10. So that means d equals to d into 10, right? So these are some assignment operators. Okay, now comes the real stuff. So these are some very basic idea about Python. So the basic things you need to know before writing the codes. So these are the control flow statements. What are control flow statements? Control flow statements, you may know about them, the if conditionals, for loop. If you know something about programming, you may know that there are conditions like if, or the loops like for, while, and etc. So these are the control flow statements. Control flow statements are essential in Python as they allow us to control the order in which the code executes. With control flow statements, we make decisions, repeat actions, and choose among multiple paths in our code. Right? These are the control flow statements. They allow us to control the order in which the code executes. This is very important, that the first type of statements we are going to learn is the conditional statements. What are the conditional statements? The first one we are going to learn is if, elif, and else. So conditional statements allow us to execute code based on certain conditions. And this is the syntax for if, elif, and else. So how to write these conditional statements? Let's see. This is the syntax, that first you write the if, then the condition, and then the code to execute in the if condition, and then elif, then and else. So let me show you an example, then we will discuss about the syntax. It will be more clear now. So suppose you have a variable known as temperature, and temperature is equal to 25. Suppose the temperature in your room is now 25. Now you write if this temperature is greater than 30 with a colon, and here you skip 4 spaces, 1, 2, 3, 4. This is known as indentation. Why this indentation we are doing? That means this code here is for this if block. This indentation, this 4 spaces I am giving, represents that this code here, written here, everything written here is for this if block. If this if block is true or false, this code will be executed or not. Similarly for elif also there are 4 spaces. So here in Python we do the indentation. This is known as the indentation. Let me write indentation. We do the indentation by leaving 4 spaces, 1, 2, 3, 4. 4 spaces. So if the temperature is greater than 30, print it is a hot day. Now if this temperature value elif is greater than 20 and this was greater than 30, if this is greater than 20, then it is a nice day, and else it is bit chilly. That means if the temperature is less than 20, then it is a bit chilly in the room, right? So one of them will be executed. Either this line will be executed, or this line, or this line. It depends on the value of the temperature, right? So here in the if, first write if, then the condition, what condition you have to do, then colon, and then do the indentation, and then below it write code to execute if the condition is true, and else if, then another condition, if this condition is true, then below it write the code to execute if the above condition, if this condition is false, but this condition, if this another condition is true, and then else, then write below code to execute if all the previous conditions are false. If all these conditions here and here are false, then here you write the code to execute if all the conditions above are false. So this is the syntax. Here you write if, elif, and else. This is the condition. These are the conditions. After if, elif, and else, write the conditions, and then you write the code to be executed. If you now, if I write temperature is 15, what it will print? It will print, it is a bit silly here, right? So these are the conditional blocks. Then loops. How to do looping? Loops allow us to repeat a block of code multiple times. Two main types of loops in Python are for and while loops. So what are loops? Loops allow us to repeat a block of code multiple times. So first let's see what is a for loop. There are mainly there are two types of loops, for loop and the while loop. Let's see the for loop. A for loop iterates over a sequence like a list, tuple, string, or range, and executes a block of code for each item in that sequence. So here is the syntax for a for loop. Okay, so let me show you an example. First I want to show you an example. For I in range, so here is the for. This for is coming here. This is for I in the range 5, print iteration I. So what is this range? This range, it will give you this range 5. It will generate numbers 0, 1, 2, 3, 4. This range is a sequence type. So let me show you again. When we discussed about different sequence types, here in the sequence types we discussed about list, tuple, and range. So I forgot to discuss about the range. So range is a sequence type. If you write range 5, it will generate numbers from 0 to 4. If you write range 6, it will generate numbers from 0 to 5. So represents a sequence of numbers. This range represents a sequence of numbers, and it is often used for looping specific numbers, a specific number of times, right? So this range is often used in looping, this range type. Okay, let me go back to our discussion. Yeah, so here this for I in this range, that means this I will be 0, 1, 2, 3, 4, and then this, and if this I is in this range, then print this iteration. This is just a string and comma I. So it will print iteration 0, iteration 1, iteration 2, iteration 3, and iteration 4. Now if I change it, this range to 7, it will grow from 0 to 6, right? So that is how the for loop works. For the for loop, you write this this variable in the sequence, and then you write the code to execute, and giving 4 indentation again, 4 spaces, 1, 2, 3, 4. There is indentation also. That means this code is for this for loop. For I in this range, you write print the iteration I, print I, or just print I. print I, it will give you 0 to 6. For I in this range, print I, right? So it will give you all the numbers. Then while loop is also like for loop. So a while loop keeps executing a block of code as long as a specific condition is true. Suppose you are writing this program and you want to count numbers from 0 to 4. So first you define a count equals to 0. While this count is less than 5, print the numbers, right? Suppose you count it from 0 to 4 and it is less than 5. So until this is true, this while condition is true, this will print, right? And when this count becomes 5, it will stop. Now if I change it to suppose 8, then it will count from 0 to 7, right? So this while, what is the condition? What is the syntax? It is that while you write the condition, and if this condition is true, then this code will be executed, otherwise not. Is it okay or is there any doubt so far? Okay, Tushar. Now let's discuss a few more things. Then will end the class. Then there are something known as the loop control statements. We discuss about the loops, the while loop and the for loop. Then let's discuss about the loop control statements. The loop control statements are 3 types. One is break, then another is continue, and then another is pass. Python provides additional control statements to manipulate the behavior of loops. If you write this break exits the loop immediately, even if the loop condition has not become false. Suppose you want to print some numbers for the number in the range 10. Suppose you want to print from 0 to 9, and here there is a condition that if number is equal to 5, break, and if it is not equal to 5, then print all the numbers. When this number becomes 5, due to this break, the loop will stop. That means it will print from 0 to 4 only. So this break thing here, due to this break, the loop terminates, it closes immediately. Now if you write this number is equal to 6, then it will print from 0 to 5. When this number becomes 6, this loops terminate, right? So the code exits the loop immediately, and even if the loop condition has not become false, you will exit the loop. Then what is continue? Continue skips the current iteration and moves to the next one. So unlike this break, it will not terminate the loop. It will just skip that loop. It will just skip that current iteration. If number is equal to 2, then continue. Just forget about that number, then continue. Suppose it is 10. For number in the range 10, if number is equal to 2, continue and print everything else. So you see that here it is 0, 1, 3, 4, 5, 6, 7, 8, 9. The 2 is absent, right? So it is skipping the 2 value, or it is now if it is 4, then continue. Skip the 4 value. If number is equal to 4, skip it, then continue the loop. There is no 4 value here. And here another thing, pass. Pass, it does nothing. It is just a placeholder to define an empty code block. This pass does nothing for the iteration. If there is if this is suppose this is in range 10, and if the number is equal to suppose 5, it will do nothing and it will print all the numbers. This pass does nothing in the loop. It is just a placeholder used to define an empty code of block. If there is nothing to write for this if block, you can write it as just pass. So these are the 3 loop control statements: break, continue, and pass. This break will exit the loop immediately. This continue will skip the current iteration in the loop, and this pass does nothing, it is just a placeholder. Then there are exceptions. Suppose you want to divide this 100 by some by 0, then you know that you cannot divide by 0 in mathematics, so you can use the try and except method. So this is known as the exception handling. You may write that you just try to divide 100 by 0, except if there is a 0 division error, you print that we divided by 0. This is sometimes useful, this try and except method. This is known as the exception handling. If there is something, some error like this is 0 division error, you can write that except the 0 division error, print we divided by 0, right? So that is how, if you don't want to give an error and run the code smoothly, you can write this try and except. Then there are functions, and we are going to discuss about functions in the next class, right? So tomorrow, that's it for today. Tomorrow we are going to discuss about the functions, and that is it for today. In the next class, we will discuss about the functions and NumPy, and that will be the end of our tutorial on Python, right? So is there any doubt from this class so far? Okay, Tushar. And Ayush? Hello. Is there any doubt from this class? Okay. So is it boring or is it good? Yes. So you need to learn all these things by yourself first. It is not, yeah, it is not very, it is not very comfortable when another person teaching you coding, right? So when you read by yourself and do these things by yourself, right, write the codes and everything, then it is very comfortable for you, right? But I am doing this to give you just some idea, right? And you can use these codes, and I will provide it and to play with it and search more about it, right? Okay, then, so that's it for today. So let's meet tomorrow 7 a.m. in the morning, and we'll continue our discussion about Python. Okay, then, goodbye. Yeah? Bye bye. Thank you. Bye.